going to start converting between grams and moles. So let's take a quick walk backward here and think about unit conversions. When we did unit conversions, we converted from centimeters to inches or inches to meters. Do you remember what I'm talking about when I say conversions? We changed the unit. But now we're going to start looking at how we can convert between an element's mass in grams and the number of moles of that element. Okay, so do we need to walk back even further and remember what a mole is?
Oh, is it 2.0?
It's 1 AMU, right?
Nope.
I know it's to the 23rd.
It is. 1 mole of anything equals 6.022 times 10 to the 23rd of that thing. Okay, I need you to write that down if you don't know that number. Okay, a mole is 6.022 times 10 to the 23rd of anything, similar to the way we use a dozen, right? How many is a dozen?
12.
It's 12. And does it matter if I'm referring to a dozen baseballs or a dozen roses or a dozen donuts? Does it matter? No, it makes no difference. And a mole works the same way. It's just a lot bigger number. And the difference between moles and grams is moles counts the quantity of a thing. And grams counts the mass of a thing, how much it weighs. Okay, so I want to talk about this relationship here with hydrogen and oxygen. If I have 1 gram of oxygen, let's start with hydrogen actually. If I have 1 gram of hydrogen, that's equal to hydrogen's molar mass. Would we agree? My hydrogen's molar mass is 1 gram per mole. So if I put on a scale 1 gram of hydrogen atoms, that would mean that I have 1 mole of hydrogen atoms. Are we good with that so far? But if I put 1 gram of oxygen atoms on the scale, do I have a full mole of oxygen atoms? I have 1/16 of a mole because a mole of oxygen atoms weighs 16 grams. So we cannot compare two substances in grams. They mean totally different things. The mass of a substance and the quantity of a substance are way different. And so when we need to compare the number or the quantity of things, we use moles. That's a way for us to be able to compare two different compounds, apples to apples, if you will, right? The quantity of the thing, not the mass of the thing. So if I have 1 mole of hydrogen atoms, that means I have this many hydrogen atoms. If I have 1 mole of oxygen atoms, it means I have that many oxygen atoms. It's a way for us to give a good, clear picture of the quantity of the thing. So we use conversions to help us convert from an object's mass to its mole, right? To its quantity. And so we use the molar mass to help us do that. All right? So we can go from grams to moles and moles to grams, right? If it tells us we need 2 moles of something, but we need to know how many grams that is, we can go vice versa. If I'm going to convert from grams to moles, we're going to use a simple T-chart. So I'm not going to walk you through what we know for the T-chart. We're just going to kind of jump in here with an example. So I'm going to skip over a couple things here in that slide because it's just walking through what we know about how to do a T-chart. All right, let's start with this next one here. How many moles are in 74.2 grams of lithium chloride? LiCl is a compound called lithium chloride. And we're always going to start our T-chart with what we know. Okay, we're going to start our T-chart with what we know. I want to ask one more question of review here before we get moving too far, but I'm going to write what I know. 74.2 grams of lithium chloride. Remind me one more time, what is the unit for molar mass? Molar mass is measured in grams per mole. So I want to say that out loud. Grams per mole. So molar mass is how many grams are in 1 mole of that substance. That's really important for how it goes into our chart. Okay, grams per 1 mole. So we write what we know, and we know we can go directly between grams and moles because the conversion factor between grams and moles is the object's molar mass. So I'm going to get rid of grams by putting it on the bottom, just like we have in all of our T-charts, and I'm going to go to moles of lithium chloride. Right? This looks very similar to a regular unit conversion that we do. But now we've got to figure out how we put the numbers in. Okay? This right here is grams per mole. Right? There's our unit for molar mass, grams per mole. And so when we do this, we say 1 mole of lithium chloride weighs how many grams? Right? I have to go find that number. I have to go calculate the molar mass of lithium chloride. Right? Because molar mass always is the thing that goes with the unit for grams. Okay, so let's go to your periodic table in your calculator and calculate our molar mass for lithium chloride. Lithium is close enough, I think, to be rounded to 7, but chloride is not. Chloride needs to be kept at 35.5. Okay, so that means the molar mass of lithium chloride is 42.5 grams. Okay, to convert between grams and moles, we use the molar mass because there's our units right there, right? Grams and moles. All right, I've canceled grams. I'm left in moles, which is what I want. So now I just do the math, right? Multiply across the whole top, divide by the whole bottom. 74.2 divided by 42.5, and I get 1.75 moles of lithium chloride. Seems simple enough, right? The conversion is just like all the conversions we already know how to do. But now our conversion factor, instead of being in a chart, right, inches to centimeters to whatever, your conversion factor you calculate by finding the molar mass.
How many decimal places do you want?
Doesn't matter. I'm not that picky about it. I like two where it's comfortable for me, but we're going to talk about rules for that a little bit. Well, actually, we already did significant figures, right?
Yeah.
So the general rule of thumb for this would be to round it to the same number of sig figs you started with. That's the rule, but it's not something I'm going to count off for. I'll just tell you that. No. Okay. Questions with that so far? Moles always gets the 1. Okay, because our molar mass tells us how many grams is equal to 1 mole of that substance. So moles in our chart is always going to get the 1. All right. Let's try another one here. How many grams are in 0.42 moles of magnesium nitrate? MgNO3 2. So here I start with what I know, which is 0.42 moles of MgNO3 2. Now, a lot of you are going to ask me, do I need to include that compound? Do I have to include that in my chart? And I'm going to say yeah, right? Because later we're going to start being able to put multiple compounds in the chart when we compare products and reactants, right? When we compare different compounds. So for now, it's not the end of the world if you don't, but I'm going to encourage you to just make that a habit. Okay, we want to go directly from moles to grams. Can we do that? Yeah, using molar mass, we can go directly from moles to grams. So this time moles goes on the bottom, right? Because if it's here, it needs to come down here to cancel. So I'm going to go moles of MgNO3 2 to grams of MgNO3 2. What did we say moles always gets? The 1. And what do we know? What always goes with grams? Is it a certain particular number? Grams always gets the molar mass. So that number has to be calculated. Molar mass always goes with grams. So we need to calculate the molar mass of magnesium nitrate. I had it at about 148.3. I don't know if that's similar to what you had. Close? Okay. Remember, magnesium is one that is not close enough to a whole number. 24.3. We need to keep that 3 in there. Okay, and so then I check my units. Did my moles cancel? Yes, they did. So I multiply across the whole top. And I get a number that's about just 62.2 or 62.3 grams of MgNO3 2. Okay, now the last thing you do when you run through calculations like this is I want you to check to make sure, does your answer seem rational? Did you come out with a huge number or a teeny tiny number and that wouldn't make sense, right? We started with about a half of a mole. And so if I know that a mole of magnesium nitrate weighs about 150, right, I should be expecting that my number is about half or less than half of 150. Do you see how I'm checking that math just really quickly? You need to make sure your answer makes sense. Because if I had accidentally divided 0.42 divided by 148.3, I would have gotten 0.003 grams. And that should have been a red flag, right? There's no way that a half of a mole would weigh 0.003 grams, right? So we've got to make sure that we're checking ourselves to make sure, does our answer seem reasonable? All right, I want you to try the next two on your own here. They're very similar to the ones we just did together. Now I want you to try them on your own.